everyone. Welcome to the second video involving how to solve problems involving sample means. So hopefully you have the two questions in front of you. And I'm going to do the same thing I did last time, which is I will give you one example all worked out. Then I encourage you to press pause and then try to answer the second question on your own before watching the video and seeing how I solved it. Alright, so the first question. The scores of students on the ACT College Entrance Exam in a recent year had a mean of 20.4 with a standard deviation of 5.8. So that's the national average. The question is, what is the probability that the average ACT score on a simple random sample of 30 students would be 24 or higher? Alright, so let's do our four-step plan. So first, let's state what it is we're being asked to find. So we're being asked to find the probability that x bar, right, our sample mean, is 24 or higher, so greater than or equal to 24. That's what we're being asked to find. Next up, we need to plan. So we need to write down what we're told. So we're told that mu sub x equals 20.4 and that the standard deviation of x is 5.8. Now, it also tells us, it doesn't tell us whether the ACT College Entrance Exam is a normally distributed score, although almost always a large national test like this would be normally distributed. However, we can safely assume that our distribution, our sampling distribution, will be normal because of the 30. So we can say, due to the CLT, so due to the central limit theorem, since n is greater than or equal to 30, we can assume that x bar is approximately normal, and it would have a mean of 20.4 and a standard deviation of 5.8 divided by the square root of 30. Right, so you can figure that out on your calculator. You can do 5.8 divided by the square root of 30, which is 1.059. Okay, so we've made our assumptions and we've listed them all out. So then the next step would be to actually do the calculation. So we want to calculate using norm CDF the probability that x bar is greater than or equal to 24. So we draw a little picture. And if it has a mean of 20.4, 24 is going to be somewhere up here. So we're looking for that. Our answer using norm CDF in the calculator, so greater than or equal to 24. 24 would be the lower, the upper would be 99999. The standard deviation would be 20.4. No, sorry, the mean would be 20.4, and the standard deviation would be 1.059. If you plug all that into your calculator, you get a really small number, 0.00034. So our conclusion then, our conclusion would be that the probability that the average SAT score, the probability that the average SAT score, ACT score, that the average ACT score in SRS of 30 is 0.00034 or less than 0.1%. So highly unlikely that a simple random sample of 30 students is going to have an average ACT score of 24 or higher. Alright, press pause when you're ready to move on to the next question. One thing I will say, the numbers that you have on your worksheet are slightly different, so you should make sure you change them when you're doing them. I did make a couple of changes, so you should reflect that you should make those changes on your worksheet before you're ready to go. So press pause, and then you can do that problem when you're ready. press play. Alright, so welcome back. And so here we have, you've had a chance to read this. So what's the problem asking for us to solve? So state, we want to know the probability that x bar is less than or equal to 7.9. And we're going to write up our plan. So we know that mu sub x is 8.05, and the standard deviation of x is 0.2. And we do know that it starts off normal. So since the population is normal, approximately normal, it is safe to assume that x bar is approximately normal with a mean of 8.05 and a standard deviation of 0.2 divided by the square root of 6. So on your calculator, if you do 0.2 divided by the square root of 6, you get 0.082. So the standard deviation, make a note, standard deviation of x bar is equal to 0.082. Okay. Oh, that was a little too big. Alright, so it's 0.2 divided by the square root of 6. And we know that the standard deviation of x bar is equal to 0.0082. Alright, so those are our assumptions. So now we're ready to do the math. Probability that x bar is less than 7.9. So we draw our picture. We have a mean of 8.05. Here's 7.9. We want to find that probability. So using your calculator, less than 7.9. So you're going to do standard. You're going to do norm CDF with a lower bound of negative 9999999 and an upper bound of 7.9 with a standard deviation of 8.05. Sorry, a mean of 8.05 and a standard deviation of 0.082. And when you put all that into your calculator, you wind up getting 0.0331. So, my conclusion, the question is, what's the probability the mean weight of those bars will be at or below 7.9 ounces? We would say that there is a 3.3% chance, probability, that the mean weight of the 6 bars is at or below 7.9 ounces. Alright, so it's all about context. You have to write up the conclusion. Alright, so now you've seen 2 examples, and you should be ready to continue on doing your homework. So good luck, and I will see you tomorrow.